Hi everyone. So this video is going to cover 12 through, hold on, I'm looking. 12 through 20 of the Unit 3 review. Okay, so this is what I have not talked about at all in class. So 12 through 20 is brand new. And so this is, I guess, part 2. All right, so number 12. Of the coins in Simone's collection, 13/25 are quarters. Of the quarters, 2/3 of them are state quarters. What fraction of Simone's coins are state quarters? Okay, so I know my answer is going to be in fraction, and I've said of, so I know it's multiplication, okay? If you don't know that of equals multiplication, then you just really haven't been paying attention. All right, so I've got 2/3 of my coins, which is 13/25. Okay, so that's my equation, because Simone's collection is all of her coins are 13/25. Of the quarters, 2/3 of them are state quarters. So now we're going to figure out, and again, I'm going to be picky about how you write this, because really it should be written like this: 2/3 of 13/25. Okay, I can't cross cancel any which way. 2, 3, and 13 are prime, and well, 25 is not a factor of 2. So I'm just going to multiply across. Now here's where you can use some money skills. I know that 3/4 is 75 cents. So 3 times 25 is 75, or just in case you don't believe me, 5 times 3 is 15, carry the 1. 3 times 2 is 6, plus 1 is 75, okay? And then 2 times 13, well, I know it's 26, but I'll prove it to you. It's 13 times 2, 2 times 3 is 6, 2 times 1 is 2, so it's 26/75 are state quarters. And 75 is going to be divisible by, what's 7 plus 5? I wonder if I can make that smaller. Let's see, 26. Nope, I can't, because they don't have a number in common. I was thinking 3, but then, well, 26 is not a factor of 3. Okay. All right, so that's how you do number 12. So it's a pretty straightforward fraction multiplication. All right. All right, so 13. Now remember, I told you your book is trying to mess you up, so you got to be smarter than the book. So a square, do not intersign. I will admit to you, a couple years I was like, I don't understand what they're asking, because I didn't read this particular word. A square, do not intersign, has a height and width of 2.5. So that's 2.5 by 2.5. Remember, squares have all the same sides, so it's all 2.5 the way around. Will the area of the sign be greater or less than 2.5 square feet? Explain how you know. Okay, well, this goes back to the, am I multiplying by less than 1, equal to 1, or greater than 1? Well, I'm multiplying 2.5 by 2.5. So I'm multiplying 2 and a little bit more times 2 and a little bit more. My answer is going to be bigger than 2. So my answer will be greater than 2.5, because I'm multiplying 2 and a little bit more by 2 and a little bit more. And I know at the very least that since 2 times 2 equals 4, my answer will be bigger. Be at least 4. Okay. So really, Yes, it will be greater than, because I'm multiplying 2.5 by 2.5. 2 times 2 is 4. It's going to be bigger than 4. Okay? You don't even have to be a math fraction wizard to that's kind of common sense. All right, what is the area of a sign? So I'm going to go 2.5 times 2.5, because area equals length times width. Okay? So, well, 2.5 times 2.5. Now, again, this is a situation where if I do my math correctly, I can use what I've already done to work smarter, not harder. So I have to turn these into improper fractions. Just because they're the same mixed number doesn't mean I can play with them as mixed numbers. I have to change this into improper fractions. Now, in this particular question, the reason why people get it wrong is because they don't change them to improper fractions and they just try to add them. I can't tell you how many times I've gotten the answer 5 and 2 halves. That's not the answer, y'all. Okay. It might be the answer, but not because you're adding them. Or 4 and 2 halves. Okay. So let's see. 2 times 2 is 4 plus 1 is 5 halves times 5 halves, because it's the same thing. So that's 10 over 4. Nope. I'm wrong. Sorry. How about 25 over 4? I'm like, wait a second, that doesn't work. And I did exactly what I told you not to do. All right, so 4 goes into 25. 6 times, that's 24. 1, so 6 1/4 square feet. Okay, so that is my answer, because 5 times 5 is not 10/4. Mrs. Hutchins, what were you thinking? Am I tired? It's 25/4, and then 25 goes in the house, 4 goes knocking on the door. So it's 6 1/4. And I know that it's at least bigger than 4. Okay? But you have to change these into improper fractions. Okay. So that's 12, 13, and 14. 12 and 13. So now let's look at 14. So Patel, now y'all, there's boxes. And you're going to be like, oh my God, the boxes, what do I do? Don't panic. Think. Okay. And you can't tell very well because, well, it's written funny. All right. So Patel drew the area model to help him solve a multiplication problem. Well, you've drawn these, you'll be fine. Use the numbers from the list on the right to complete the area model. Okay. So this looks like it's actually going to be more than 1. And I know it, and it's hard to tell. And I'm going to tell you this right here. Here's your more than 1. There's your more than 1. All right, so looking across here, so we do columns first. So I've got 1, 2, 3 columns, 4, 5 columns. And if you can't, your book is probably better. Actually, hold on. I might actually have, you can see the picture better. Okay. So we've got the blue columns going down. How many blue columns do I have? 1, 2, 3, 4, 5. So I want to look for the numerator of 5/3. So that's 5/3. Because again, it's like if I did this. Can you guys see that? Yeah, you can see that. It's like if I did that. Okay, so that's 5/3. And then looking here, I have 1, 2, 3 is my numerator out of 4. So I'm going to use this over here to help me. It looks like it's 3/4. Okay, and I don't really care that this crosses the whole thing. It's out of 3/4. So that would be my equation. Okay, so then it would be, and let's see. So it would be a total number squares of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 12 squares. And the reason why it's not 12, not 24 is because you have to look at 1, just 1. That's where it gets kind of confusing. So we're just going to multiply it. Okay. Here's an example of where I can cross cancel. Get rid of the 3's and it becomes 5/4 or 1 1/4. If you don't want to cross cancel, it would have been 5/3 times 3/4, which would have been 15/12. 15 goes in the house, 12 is knocking out the door, that's 12. and 3/12 left over, which equals 1/4. Okay, it does easier because the 3's are matchy, so I can get rid of them. So again, if you look at it kind of as a 1 and then add these, it's harder because this would be what we'd call a mixed number, and that's why it gets a little tricky. But when you're finding the denominator, you're really only using the denominator of one of them, not both of them. Personally, I find that kind of confusing, so I would have just done the math. Okay. Without multiplying, choose the symbol for the box to compare the product on the left with the factor shown on the right. So it's more of the multiplying by less than 1, or more than 1. Okay. 5/5 times 3/8 will be greater than or less than 5/5. Well, 3/8 is less than 1, so it's going to be less than 4/5, because when I multiply something by less than 1, I get a smaller answer. 8/6 times 2/3 will be greater than or less than 2/3. Well, 8/6 is greater than 1. So the answer will be greater than 2/3 because I'm multiplying 2/3 by greater than 1. So I'm multiplying it by 1 and a little bit more. It's going to be bigger than 2/3, even if it's just by a smidge more. Okay. And then 5/5 times 3/8. Well, 5/5 equals 1, so it's equal to. Now, again, if you're not sure and you don't want to risk it, do the math. That would be 12/40. So it's less than. We were right. And then 8/6 times 2/3, which would be 16/18. No, it wouldn't. Yeah, it would. Which would equal 8/9, so that's more than 2/3. I said a little bit more, not a lot. And then, well, 5/5 times 3/8 would be 15/40, which you divide top and bottom by 5, and you get 3/8. Okay, so you could do the math to prove it, but that's what it is. Oh, okay. So again, it's more of it. You know you love it. Don't lie. You know you love it. You love it so much. Said no one ever. All right. So this is a classification one. So without multiplying, classify each product as being less than 2/3, equal to 2/3, or greater than 2/3. Write the letter of each expression in the correct box. For my people who do not follow the directions, I'm marking it wrong if you do not follow the directions. It's write the letter of each expression, not each expression. I will not count it. You've got to start getting better about attention to detail. When I tell you to write the letter and you write the equation, you're not following the directions. You guys have got to get better about that because your 6th grade teachers will not stand for it. Okay, it's not because I don't love you, it's because I want you to do well. Okay, so I'm going to start with the equal to 1 because I'm looking for all of the numbers that are 1. So here's 2/3 and 9/9. Well, 9/9 is equal to 1, so 2/3 times 1 equals 2/3. Okay, that was the obvious one. All right, now I'm going to look for another obvious one. I'm multiplying 2/3 by 2. That's more than 1. That's obviously going to be greater than 2/3. So I cross those two out. Okay, now I'm multiplying by, now I got to go back and look. Okay. Well, 8/5 is an improper fraction. And if I was going to make it a proper fraction, it'd be 1 3/8. Huh, that's more than 1. So 2/3 times 8/5 is greater than 1. It would be 16/15. Okay. And then let's look at D here. Now this one right here, oh, that's a fraction. It's an improper. Wait a second. That's not an improper fraction. It's 6. So if 2/3 times 2 is going to be greater than 2/3, then clearly 2/3 times 6, because any number over 1 is the same as a whole number is going to be greater than 2/3. So now I've just eliminated B, C, D, and F. And now less than, okay? Well, 2/3 times 1/5, well, 1/5 is clearly less than 1, so A is gonna be less than 2/3, sorry. And then E times 2/3 times 8/9, well, 8/9 is still less than 1. Yeah, it's bigger than 2/3, but it's still not 1. It's a little shy, so it's going to be less than. Okay, so basically, if it's equal to 1, it's going to be that. If it's an improper fraction or a whole number, it's going to be greater than. And if it's just a regular old fraction, it's going to be less than. Okay. I did that. Okay, I'm gonna stop the video because I'm at 15 minutes and I'll do 19 and 20 on a separate video, okay? So